Yeah,
Okay, so today's session is on the modularization techniques, okay, in the ABAP program. So if why we need this modularization, what are all the modularization techniques? So these things we will study today, okay, and we will discuss about it. So when we come to this modularization, right, when we modularize the source code, we place a sequence of statements in the module. So it is a reusable component actually. So sometimes what happens is when we write piece of code, some kind of like reusable component, we can keep it in the module and we can use it multiple times throughout the program. That way our performance of the program will be improved. Also, like it will be easy to read the code, it will be easy to maintain the code. Also it will avoid the redundancy and promotes the code reusage, right? So there are few types of modular, like, or the techniques of the modularization. Okay, so first is this macros. So if we want to reuse the same set of statements more than once in the program, then we will include them in a macro. So the like if you see the syntax macro is defining macro syntax, okay, and so and calling macro define inside this define macro and define, and then calling macro syntax is this, like you will call that macro, right? So macros can also be useful for long calculation or complex write statement, okay. So it can use the parameters like ampersand n, where n will be equal to 1 to 3. So let's check the macros here. So let me create a program for the modularization techniques as a whole, and maybe executable program will create, okay, under the same package. So this is visible, right? Yeah.
Yeah, yeah.
So, so first technique is this define, so macros, right? How to use these macros. So what was the syntax? It is like defining the macro syntax is define and define. We will define a macro and then we will call the macro. So let's follow the same thing. So what I will do is I will create a this one number or num whatever, type I, value 1. Okay, so you will see how you can reuse this thing. So I will define the this macro, define increment. So after this, macro definition. Okay, so this ampersand one, which I was saying, right? This belongs to ampersand n. Okay. So as I said to you that the macros will be can use the parameters ampersand n, where n will be equal to 1, 2, 3, whatever. Okay. So this will be taken as n variable. Okay. So we will see by writing ampersand 1, okay, and then end of definition. Okay, we'll do a pretty printer. After that, this is the define syntax. Then we will calling syntax. We'll call this macro which we declared, and then we will call the variable increment number, then write number, right? So here we have defined the increment. This is the macro. Okay. Then we are giving some calculation to the ampersand n, and we are writing that value. And then for calling the macro, what we are doing, we are just saying that you increment that particular number. So now let's see. This is pretty fine. So we will just debug and we'll see how it works, right? Okay. Okay. So first, what happens is it comes to the line number 20, right? So this is that macro. So what it will do, it will call the number. Okay, so number was first, value was equal to 1. Then it defined that statement, added that one, or maybe what I'll do is instead of doing this, I'll keep the value here. Inside it is not allowing. Okay, always at the load of the program, the debugger it's set. Anyway, so you understood, right? Like what is happening is here we have defined a macro. We are adding the one to that ampersand n, and whenever we are writing that, it is calling that increment number. It goes back. Adds the one to already existing value of the one, and then that is how it is giving the value, right?
Yeah, yeah.
Yeah. Okay. So this is one thing. Then the next part is your include programs. Okay. So if we want to use the same sequence of statements in several programs, right? We code them in one. So here it is written in the same program, and we are able to use that macro in that same program, right? But in case of the include program, when you create that, that can be used by multiple programs. Okay, if you include programs cannot contain program or report statements, it will not be an executable kind of program. Okay, so whatever we are creating right now, these are type of report program which are executable. But when you try to create an include program, it will not be executable, but rather it can be used by other programs, and it cannot call themselves. It must contain all the complete statements. So let's try to see how we can use a this include program in our case. Okay, so let's go here. So this one was macro. Now the include demo. So what we will do is, before that, we will create a include program. So if you see from here itself, you can create an include program. Okay, say we will give z include some name I'll give, like include demo. Okay, something like that I will create. here it is like demo on the include. So here if you see, the type will be include. Okay, you got my point. So you save it. Okay, it doesn't have that report statement, correct? So here whatever we write here, like say I'll write here like write something. We will use some system variable. So user is unim and date is datum. Oh, sorry, you must not be able to see this. Now it is clear, right? So datum. Okay, and we will just display this one. So our include is ready. Now we'll go here and we will call that same include in our program. Include was that GI demo was there, right? GI demo. Okay. Now, if you see this, so it directly went to this demo. Okay, include demo, and when you execute it, it shows you the username and the date. You got my point, right? So this include which I created independently, it can be called from any programs. Okay. Why we need this include is whenever you are going for a real-time project scenarios, right? What we do is you have seen that we are designing the selection screen, we are declaring the variables, we are doing some fetching of the records as well, right? At that time, you can modularize this piece of code. So one include you can call for top, okay, which will have all the data declaration. One include you can call for selection screen, where you will use your parameters and select options, okay, and another include for the fetching records. So in that case, you modularize the code. So whenever somebody comes here, he will not see all the piece of code in the program. So it will be a very readable kind of program. So when like what happens is clean code and less code is the new trend, right? So we don't want to use a program where there will be like thousands and thousand lines of code, and tomorrow once you leave the organization, tomorrow another person comes, like it will be very difficult for him to understand it. So to make it readable and to make the codes reusable, we use this modularization technique. Okay. Then the next part is subroutines. Okay, so this is the syntax which we saw. The next part is the subroutines. Subroutines, like program module that can be called by another. Again, this is also like another technique. So these are the procedures that we can define in any ABAP program. Okay, and also call from any program. So subroutines are normally called internally. Generally, in that same program, we will be using the subroutines that can contain the sections of the code which will be used locally. Okay, but if we want to use the function like from other programs, in that case we will have two types of subroutine. One is the internal subroutine, which will be used in the same program. Okay, it can access all the data objects declared in the same program. And in case of the external subroutine, the subroutine which will be defined outside the program. Okay, in that case we need to use some parameters to declare the objects in that common part of the memory. Okay, so we will also see then. So this is the syntax of the subroutine: form and end form. Like calling syntax of internal subroutine will be perform subroutine, and then you pass either the parameters can be passed and name of the subroutine, and these are the syntaxes for the external subroutine, where you will have to pass the program or the passing parameters, right? So let's see that as well. So there are, yeah, okay, passing parameters. So let's see the for the subroutines as well, the demo on that. So what we will do is there are three types of subroutine which you can create. One is, say for example, the normal internal subroutine what we try to create is this. So let's say subroutine. Okay. So what we will do, right? Okay. We can use either pass by reference. Okay. When we pass the parameters here, either we can use pass by reference or pass by value or pass by value and result. Right. So there are three types of ways where you can create your subroutines. So first is the pass by reference, which we will see. Pass by reference. So what we will do is we will define a variable f1 value, something like a or 1 or whatever. Okay, and then we will use a perform statement here. Okay, perform. What will do? P1 using f1. Okay, so this variable we will be using it here using the f1. So when you call this perform p1, when you double click on it, the subroutine p1 doesn't exist, so you create an object. Either you can create in the include what I said, right, for the fetching of the data or whatever, or you can use in the same program, right? So you can use in here. So in this way the form and end form will be created. So here what I will do is I will use a pass by reference value on p1 using whatever we have passed it here, right? So we will declare a variable, say p2. Okay, and then we will p2 equals to x. I will just make you understand how it works. Okay, like this, let's say we pass it. So what we are doing, first we are declaring a variable. That variable value is a. Now we are using a perform statement, which is a type of a subroutine. Okay, so in this case what we are doing is we are passing this using f1. So when we are calling this form p1, so this variable whatever is there, we are passing it by reference to p2. Okay, the value would be same, and now we are trying to change the value of that p2. So we will see what is the value at the end of the f1. Okay, so let's execute it and we will try to understand what is happening in the pass by reference. Okay, so if you can see this, so first of all, what is happening? This f1, it allocated memory for like whenever we are declaring this line data, memory is allocated for f1 where the value would be a, right? Now when it comes to line number 33, okay, so whenever it calls this, it directly goes to this form statement, right? It transfers to this control line. Okay, now what we are doing is it actually causes this line, it actually causes the f1, this f1 to be passed by reference. Okay, so now if you see, the value of the f1 is right now a. Okay, So if you see this, P2 value is also A. Whenever we are passing using F1, this P2 value is also equal to A. So in the runtime, whenever it comes inside this, the value becomes X. Okay. And after that, it goes and write the value of F1. Okay. So after that, the value became X. Modifies that memory location when we are passing that reference. So what happens here? Both are passed by reference to this variable. Therefore, what this one, whichever we are using it, P2, it is a pointer to the already referenced variable. Okay. So this value we are passing, but we are using another. You can use the same F1, F2 also, or F1 also. You can use this variable, whatever you are using. It is just a replica of this one. Then you are trying to change that value to X. So whenever it comes out of this, it changes the value of that variable. Okay. One more thing is called as pass by value. So now you will understand the difference here. What happens when we pass it by reference and what happens when we pass it by value. Okay. So pass the parameters by value, passing by value. Then maybe you will be able to understand this. Okay. So we will just do this, remove this. Here what we'll do, again, we will create this F1 value, the same variable. Okay. We'll perform say S1 using F1. Okay. Write F1. And then you double click on that perform statement, it will automatically create it actually. So we'll use this. Okay, it's better. So you can see that they have assigned like from the standard itself, they have assigned this one. So what we will do is we will use here using value something called as P1. Okay. Now we will assign this value here. Okay. And then we will write the P1. Now you see the difference between the pass by reference and pass by value. Okay. At end form. Okay. So let's put a debugger here. So first, this line, okay, it allocated the memory for the variable F1. Okay. So when we are putting the debugger here and pressing F1, so it transferred that line to here, right? 61. So now what happens is this line causes the F1 to be passed by value to P1. Okay, so P1 now refers to a new memory location which will be independent of F1 because we are passing it as a value. So if you see this, see the value of F1 is A. Okay, the value of F1 is A, and let's see the value of P1 is also right now A. But what happens here? So when we are assigning a value, it becomes X. Okay. And then when we write it here, the value becomes X. But once it comes out of this end form, the value again changes. Okay. So now see the value is not retained. So what will be the result of this one? A and X. Correct? X and A. So first it is writing the value of this variable. First it is writing because the control is coming in here. It is assigning the value of X to P1. So once we write this value, then once it comes out of this end form, the value is lost. Okay. then it is writing the original value of the A. But here what was happening when we were passing it by reference? So this value is getting retained. So whenever we are modifying the value, that value is retained even after coming out of the end form. Am I clear, Babu? Pass by reference and pass by
Yeah,
value.
yeah.
It's very important actually. Okay. So use the pass by value when we need a local copy of that variable. Okay. So that we can change without affecting the original value. So whenever we are not intending to change the original value and we want to change the modify the local copy of that variable, at that time pass by value is used. But pass by reference is more efficient than pass by value. Okay. Whenever we need an independent copy of that variable, we use the pass by reference. Okay. Now there is one more thing called as passing parameters by value and result. Okay. It's also similar to your pass by value, but there is one catch in that pass by value with result. Let me show you that as well. Okay. So pass by value and result. Data F1 value A. Okay. And here we'll take another variable. I'll just tell you why we are using this another variable. Okay. So first of all, we will write the values of here. Okay. Just to understand F1 and F2. Okay. Now what we will do is we will use perform S1 using okay, call by value, right? Okay, there is one more thing called as even the changing. Okay, so I can make use of this call by value also. There are certain things called as using and changing parameters. Okay, so that I would have shown you in the pass by value itself how it works. But let's go here itself. Okay, so what we will do is using the value or maybe the F1 change we will use it here changing F1. Okay, and then S2 another perform I am calling S1 changing value, we'll use a variable P1 and then we will assign P1 equals to B. It is form. And then the next form S2 changing value P1. Okay. P1 now what we will do is we will assign it as X. That's it. Comma without preceding colon after perform. Okay, yes, right. So, okay. So now let's try to understand what we have done here. Okay. See, we have seen this pass by value. So whenever we are passing the value, locally it is changing. Correct? Okay, but if we give this stop, so what will happen is it will not allow to modify that piece of it will not allow you to modify this variable. Rather, what was the original variable that it will retain. Okay, so let's see what is happening here, and we will just try to debug and see. Okay, so let's do this. So generally what happens is it is very similar to pass by value, but like pass by value, a new memory area is allocated and it holds an independent copy of the variable. But whenever the subroutine ends, that memory is freed. Okay. The only difference occurs whenever we have where the copy will always take place unless we leave the subroutine by using this statement called as stop. What it does is the stop statement will terminate the subroutine and goes directly. So if we give here, now it comes first to the perform statement. The first value is F1 equals to A. Why it changes the size? I don't understand. Yeah. So first it goes to F1. Okay. It assigns this value P1 equal to, first P1 was equal to A. This right will give A. Right. This is clear. Now it assigns this value P1 equals to B. Okay. Then it goes to the next S2 statement. Okay. Here when we press F1 again it comes here, okay, and we are again trying to modify the value of P1. So P1 became X but only locally here. Then we are pressing stop. So when we press stop it directly came to this right statement, right, stopped value. Okay, now F1 became B. So what will be the result? A and B, correct? So for the value will be A and stopped F1 equal to B. Now let's say I don't use the stop statement. Okay. I don't use the stop statement. Let's see what will the value in that case. Okay. Let's execute it. This is the only difference between that pass by value and pass by value and result. Okay. So when you come here, write F1, first value becomes A, then it goes inside this. We are assigning the value as B. Okay. It goes to again S2. It comes here. The value of the P1 became X right now. Okay. And then when we are writing it, now just see. Okay. A and X. Okay. So now the next part, so these are the methods of passing parameters, calling by reference, calling by value, and calling by value and result, correct? So we saw that. Now there is something called as we can also pass an internal table through this passing parameter. So in that case, what you will use? So how we used using changing also. So there is something called as tables also. Okay, you can pass the tables. You can just explore that, or else if you have some doubt I can show you like how you can pass an internal table with a header line or without a header line, and then ultimately you create a header line. Okay, so something like that we can use. Okay, and there is one more point which is called as an external subroutine. Okay, so in this case what happens, your subroutine perform statement will be one program. You can call that perform statement using the parameters you have defined in the external subroutine. Okay, so what you see is after both these external subroutines are very similar to routines. They allow the parameters to be passed, allow the type parameters, and both also allow this passed by value, passed by result, and passed by reference. Okay, so what we will see is like that there are certain differences between the external and the internal parameter as well. So I can show you how we can call one external subroutine from another program. Just let me this. So something called as external subroutine. So what we will do is we will have to declare one more program here, external subroutine. So okay, I will create another program for external subroutine, and then I will call it, because I have to call it from another program, correct? Like how we called the include. So I will just create another program and let this be my main program. So I will just use external subroutine. Okay. And I will just create external subroutine demo. Sorry. This will also be a type. System is slow. So executable program. So here for external subroutine, first what we will do is we'll use something called as we can use some local table if I can use, that is also fine. Or in that case, a structure I can also use. Okay. Have we created any structure in our case? Or else directly instead of the table, let's use only a variable. Okay. I will just declare F1 type char3. Okay. And in here, what I will do is form S1 F1 equals to I'll assign a variable called as A, B, C. Okay, and then I'll make it as end form. Okay, let's do this, and then okay, this got this one. Then what I will do in my main program, so I will call this data F1. Let's take type character, but the value would be value would be suppose BBB. Okay. Now I will perform S1 and we will pass the program name, this program name. Inside this, and we will write, okay, F1 equals to F1. Let's see what happens here. Okay, so let's put the debugger here. Okay, this is how you will call an external subroutine. So let's see how it does. Okay, we took a value, F1 value is BBB, right? So now, so we are calling this perform. So what it will do? It will go to that other program, right? So it comes to this Z external subroutine. Then what it does, the value of F1, it modifies to ABC, correct? Earlier it was BBB, it modifies in this external subroutine as ABC. After that, we write the value of F1. Okay, so the value becomes BBB, correct?
Yeah.
Yeah. So this is how you will call the subroutine.